This is triangle congruence using angle, side, angle, and angle, angle, side. So it's just like side, angle, side, but now we have two more to add to the bunch. So they use the abbreviation ASA, standing for angle, side, angle. Okay? Then they use the abbreviation AAS. So that's angle, angle, side. And as a reminder, I will throw in there SAS. So the three, oh, forgot side, side, side. Is there any more that I'm forgetting? Okay, didn't think so. All right, so there are the four that we have currently to identify congruent triangles. Okay, we use these to ultimately get to C, P, C, T, C, corresponding parts of congruent triangles are congruent. Call. Okay, that is just another reminder for what that abbreviation truly stands for. It is on your test, and it is a really easy one. So that's another easy one for you.
Wait, do we have to put all that on our test, or do we just start with
CPCTC?
And that'll be the answer.
Indeed.
Has anybody commented on your videos yet?
No. All right, so here we go. This is postulate 16. ASA is postulate 16. It's a congruency postulate that says, pay attention, if two angles and the included side of one triangle are congruent, two angles and the include side of with the two angles and include side of another angle, then the triangles, therefore, are congruent. So from example 1, we will see these two triangles, one going upward and the other going downward. And we have to prove them to be congruent. So it says, on triangle ABC, we have one arc mark on A, two arc marks on C. We have 18 to mark AB and 17 to mark BC. And lastly, we have one arc mark, or sorry, tick mark on AC, which is 6. Okay. Then we have triangle FED. On angle F, we have two arc marks. On angle E, we have one arc mark. And then on our base, which is FE, they give us one tick mark. Okay? So, from this, I'm going to state the things that I know to be congruent. Okay? First thing I know to be congruent is angle A and angle E. So angle A is congruent to angle E. This would be close to developing a proof, right? Angle A and E are congruent. We know that angle F and angle C are congruent. And then I know angle AC and FE are congruent, right? Sorry, did I say angle side length? AC is congruent to side length FE. Okay, so I know three things. I know an angle, and a side. So what do you think I should probably use? I know an angle, and a side. It's like I said it out loud, huh? So we have angle, side. That would prove these two congruent. Now, the definition gives for us, it says the included side of two angles. So notice these two angles are the ones that are congruent in this one. Therefore, the included side is the one that is in between them. I can't say 17 in... I can't say BC and FD are congruent to each other and then use angle, side, because it's not in between angles A and C. It has to be the angle in between for it to fall into that category. Okay? So using angle, side, I can state that the two triangles are congruent. Now what's important here is order. So triangle ABC is congruent to, and I have to look at what angle is congruent to A, it's E. So triangle E, what angle is congruent to B? it's D. What angle is congruent to C? That would be F. EDF. Order is very important here. That's what will get you in the most trouble on your test when it comes time. Okay, you have to put them in the proper order. Questions there? Okay, so it wants us to determine the measures of each side in triangle DEF. So in triangle DEF, there are 3 sides. I need to name them. First one, FE. Next one is DE. And then FD. So we need to name each of these sides. Then we need to find what is their measurements. So the easiest one is FE. What is the measure of side FE? Looking at the tick marks, what does that tell you? That they're equal. So what is the measure of FE? 6. Good. Now looking across from angle A, okay, so the one with 1 arc mark is 17. I want to look across from angle E to know that FD is also 17. I'll just write it in. Okay, FD is also 17 because it's across from that angle. And then leaving the other side to have to be 18. It doesn't give us any unit, so we'll just leave it. Questions? Alright, here we go. Example 2. Gives us a nice little picture here. See if I can draw this correctly or not. Yeah, pretty close. So I have S, and then the intersection is at T, and then U, and WV. It marks these two to be parallel to each other. Alright, so look, it says to prove the 2 triangles congruent to each other, given that T is the midpoint of WV. Okay, if T is the midpoint of WV, what do I know about WT and TV? They are what? What does the midpoint do? Okay, here we go. What do we know about WT and TV? They're congruent. They're equal to each other, right? So I can state that WT is congruent to TV because of the definition of a midpoint, right? So now I have this side and this side that are equal to each other. Next, let's look at what it tells us about VU and WS. It says that they are parallel. So I'm going to pull these out, just set them aside for you. Here is the line SW. SW. Here's the line VU. I'm going to draw WV, the line WV, as a transversal in between them, just so that I can isolate, if this is W, so I can isolate this angle right here and this angle right here. Okay, what do I know about this angle and this angle? They're in the same what?
Same side.
They're on the same side. Are they in the same basic position? So what are they called?
Correspond.
They're corresponding angles, right? And looking at the top part of V straight down, that must mean that this one is congruent to it by what? They're directly on top of each other? No.
So,
If I ask you, yep. It's a vertical angle, right? These are vertical angles, a definition that we went over a bunch. These are vertical angles. So I know that this angle, in other words, this angle right here, is congruent to this angle, or in other words, this angle right here. Okay, so I know those 2 angles to be congruent. But I had to pull them apart to be able to see that. So I know that angle W is congruent to angle V. I have a side and I have an angle, so I'm looking here, side and angle, side and angle, side and angle. The only option that I've eliminated is side, side, side so far. Okay, if I'm looking here using that same definition call, what do I know about this angle right here and this angle right here? They're congruent. Why? Angle. They're vertical angles. So angle ST TW is congruent to angle VTU. Again, because of vertical angles. So now I have an angle, I have a side, and I have an angle. So I should probably use angle, side, angle, right? So by angle, side, angle, I can state the two triangles congruent, but I have to be very careful in how I name the two triangles. I have one triangle, which I can just name, and then the other one has to match. So I'm going to say triangle STW. So triangle STW. Now I'm going to look at the next triangle and try to name it the same way. If S is the one without a congruent mark, an arc mark, and U is the one without an arc mark, I can do U first. And then T is in the same relative place, and then the last one is going to be V. So I have triangle STW and UTV. Okay, I just need to be careful about the way I mark that. And that is true because of angle, side, angle. ASA. Okay, those are congruency theorems. I need to recognize these because we're going to have to put them in proofs very quickly. We're going to have to put these into proofs. So we need to notice these things. All right, here we go. If I have, this is example 3, by the way. Yes. Sorry, I didn't see.
Okay, why is it why is it UTV?
Okay, so you said why is it UTV instead of VTU? Okay, I want to look at the relationship of W and V. We know they're congruent, right? Yeah, so if W and V are congruent, then W and V need to be in the same places when I name the triangles. So if it's in the last spot here, it has to be in the last spot here. Did that help?
Yeah.
Okay.
Well, you put that on your test or whatever, you get it on.
If you put them out of order, yes, you would get them wrong. Because you're naming a different triangle than is actually there. You have to name them in correspondence to each other. Because from this, I ought to be able to write my 6 congruency statements without seeing anything else. I ought to be able to say angle S is congruent to U, T is congruent to T, W is congruent to V. And then I'd be able to name all the sides, ST and UT, TW and TV, and then VU and WS. I ought to be able to do that just by looking at the congruency statement right here. Without even having to look at the triangles, I ought to be able to do that. Okay, anything else on that one? Goody. All right, here is my horribly drawn triangle, but a triangle nonetheless. It is EDF right there. It has 4x minus 2 on bottom. It says that it's a right triangle, and it gives us a 6 up here. Without looking at my other options, what would I initially think to do with this? If I wanted to find the unknown length on this side, what would I think to do with it? I would use what? Pythagorean theorem, right? I would use Pythagorean theorem. However, I haven't taught you guys a whole lot about solving this when it gets squared. So it's not a good option for us. But it does give us another triangle, so that's nice. It tells us by the tick marks that L and D, sorry, it looks more like a P, L and D are congruent, right? So angle L is congruent to angle D. I can see that because they put a arc mark on it. Why do I know M and F are congruent? Because they're right angles, and by definition they're both equal to 90, right? Okay, so I have 2 angles. I need to prove something else equal to be able to say that they are congruent. What side would I need to prove congruent? The one with the 6 on it. So he says side DF. And in this other triangle, what is the corresponding side? LM, right? Is anybody confused as to why it's LM? Okay, I would need to prove that those two are congruent in order to do this. So it says given that DE is congruent to LK. So it says DE is congruent to LK. So we need to mark that in, too. So let's look what they gave us. This is what we needed, right? let's see what they gave us. They gave us a side, an angle, and an angle. Is there a thing that we use that involves two angles and a side? AAS. So, since they gave us that DE is congruent to LK, I can now say that these two triangles are congruent to each other by angle, angle, side. And because they are congruent to each other, I now know that DF and LM are congruent. So I can go ahead and write that in and make this statement true. What do I know about KM and FE? What do I know about KM and FE? They're also congruent because the whole triangles are congruent, right? So if they're congruent, what can I do with their equations? I can set them equal. If they're congruent, I can set them equal to each other and solve. So now that I got to this point, I just need to set them equal to each other and solve. I'm going to move my variables to the left and my numbers to the right. So plus 2. I'm left with 4x equaling 3x plus 3. I'm going to subtract 3x. And I'm left with an x equaling 3. So that solves for x. I need to make sure to answer the question. It says find the area of the triangle shown. How do I find area? Base times height. Good call. So I plug it in to find my base. So I go 4 multiplied by 3. I could plug it into either one of them. It doesn't matter. 4 multiplied by 3, subtract 2. So that's 12 subtracted from 2, and that gives me 10. So base times height, then we need to do what? Divide it by 2. So I have base of 10 multiplied by a height of 6, and I need to divide it all by 2. So I get 60 divided by 2 equals 30. And I need to make sure to add in my unit. Let's see. Did they give us a unit? No. So just units squared. Questions? The proofs are the hard part, of course, but in order to get to this point, you have to be able to at least prove to yourself without writing it on paper that you know how to get to that point. What? A proof? Yeah. Alright. I think there's just one more example. So make sure you're looking at it. It is example 4. Does it have an example 5? Oh, that does. Guess we're going to do example 5 too. So here we go. It says BD bisects. What is the definition of bisect? Look up the definition of bisect while I'm writing this down. Okay, do we got a definition? So bisects means that it's to be divided into two congruent parts, right? So looking at the picture that they provided for us, which is right there, says that it divides it into two congruent parts. So BD, which is this piece right here, BD, bisects ADC. So I'm looking for, well, turn right back up, ADC. So it bisects this right here and creates two congruent angles. So I can use that to my benefit here in a second. That definition will be used to my benefit here in a second. Okay, you have to be very careful when we're writing down our given, because this was given to us two things. Okay, so it says angle A and angle C are congruent and BD bisects ADC. And using that definition of bisects, we can state that two other angles are congruent. So by using the definition of a bisect, I'm sorry, say that again. Are you talking about this picture? I'm not sure what angle thing you're talking about, Carl, to be honest. Okay, this is an angle bisector, if that's what you're talking about. This cuts these two angles in half. So I'm going to call it CDB and ADB. Angle CDB is congruent to angle ADB because of the definition of a bisector. So now, looking at my picture, I have an angle, and an angle. So I have two angles that are equal to each other. I want you to see this triangle as two separate triangles. So I'm going to hold a piece of paper over it. Here I have I have triangle ADB. And then if I cover the other side, I have triangle DBC. What can I prove? Do I have anything in my repertoire here, my little toolbox, that will allow me to prove these two triangles congruent? Remembering my options. So if I have two angles, so it can't be side, side, side. It can't be side, angle, side. It has to be either angle, angle, side, or angle, side, angle. So let's look where my stuff is. Call says angle, side, angle. Let's see. If it's angle, side, angle, I'd have to go angle, side, angle. If I was using angle, angle, side, it would be angle, angle, side. So which one matches? Angle, angle, side. So what do I need to state is congruent? I need to state side DB is congruent to what? Remember, when I pull these out, there's two triangles. Yep, say it louder, Carl. That was not louder, but I'll take it.
DB is congruent to DB.
Now you're my hero. So what property allows me to say that DB is congruent to DB? Anybody disagree with that statement? Okay. It's the reflexive property of congruence, because I used the congruency symbol, right? So now that I've stated an angle is congruent to an angle is congruent to an angle, and a side is congruent to a side, I can now use angle, angle, side to state that the two triangles are congruent, but I have to do it in a specific way. Okay? So triangle ABD, the first one is just however you want to order it. The second one, you have to go in a specific order. If I chose A and A is congruent to C, then I have to say triangle. I start it with C, and then I look at what other angles were congruent. This two angles were congruent, so I'm going to go D and then B. CDB. Questions?
Nope.
Did I do that backwards? No, I didn't. Yes, I did. Okay. Anyways, that works. Any questions, comments, concerns? Okay, on 5. What we do. The reason we do is because I want to break down the picture for you. That's it. That's all I want to do. Okay? So look at the picture. I'm going to put it right there real quick. I want you to break this down into two sets of lines. So I have BD and AC, so that's what I want to look at. I want to look at BD and AC as a set of parallel lines. Whoops, sorry. They're not congruent, they're parallel. There's a difference. So there's BD and AC. I just want you to look at them as a set of parallel lines. And then the other ones, looking at those, okay, they were this way, right? So that one's AB and CD.
Is that why you have two digits in the last one?
Yes. So the reason for this is because it's really hard to see all of the things that they want you to notice in the first one. Okay? It says that BD is parallel to AC, so we drew it. BD parallel to AC. And then it says AB is parallel to CD, and so I drew it. Next, I have to prove that triangle ABC, so I'm looking here, triangle ABC is congruent to triangle DCB, and I have to figure out why. So let's look. I have these two lines, okay, and they're connected. Okay, here's my transversal that's drawn through here from B to C. I guess I should have drawn it from B to C like they did. So here it is, from B to C. Okay, so if I'm looking at this and these are parallel lines, then I know that this angle right here is congruent to this angle right here because they're alternate interiors, right? I can see that they're alternate interiors when I break it up, but it's hard to see when they're not broken up. They're alternate interior angles. So I want to draw the picture of the triangle that they gave us. It was A, B, C, and then they had triangle that was right here named B, C, D. Okay, so looking here, I have D, B, C. So I have D, B, C. Remember that B is here and C goes here. So this angle on the outside is this one right here. Okay, so this angle is congruent to BCA. So look, BCA. So these two angles are now congruent to each other, and I can state that because I pulled them apart. So I have an angle, I have a set of angles that are now congruent to each other, and I can see them. That was important. Next, I want to see if I can find either another side or another angle. Do you see any sides that might be congruent to each other? Side BC and BC. You're going to get to see these a lot, guys. So get used to seeing them. I have angle C and angle B that are congruent to each other here, right? And angle or side BC and side BC that is congruent to each other. So now I have a side and I have an angle. So I need to look at what options I have. It can't be side, 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 but it can be any of the other three. So I'm still looking for either another side or another angle. Looking at the parallel lines that are going this way, connecting again to B and C. Let's see. There's that line. I don't want to miss one, so I'm trying to make sure. Call. Okay, so here I can see that this angle is congruent to that angle, which we have to establish, BAC. Okay, BAC. So this angle is that angle right there. They're alternate interiors again. And we have BCD, BCD. So these two angles are congruent to each other. So now I have angle A is congruent to angle C in my picture, right? So I have two angles and a side that are all congruent to each other. So I can either use angle side angle or angle angle side. So I need to figure out which one it is. I said that BC is congruent to BC. And that's it. Is that right? So what's wrong with my picture here, guys? Are they the same?
No.
Did I mark something incorrectly? Angle, side angle, she says. According to the book. Where we messed up is I drew this one twice, and it should have been up here. ABC is ABC. I just drew it in the wrong spot, sorry. So yes, it is angle, side angle, but it needed to be from the proper spot. When I said this angle, we needed to put it in the correct place. Okay, so ABC is right here, and BCD is right here. So I use angle, side angle to state that they're congruent.